Okay, the rank of a matrix. What is the rank of a matrix? The rank of a matrix is the number of linearly independent rows and columns it has. Okay, and what are the type of rank of a matrix that we have? The method that we use to get to the rank of a matrix. Okay, and here the method used to reduce the matrix. Okay, in order to obtain the rank of a matrix. So these are the methods. So we have method 1 by normal form, by PAQ form, by echelon form, by definition and of rank. And we, as you can see, these are the what we'll be covering under this section. By echelon, we saw the Gaussian and Jordan Gauss. Okay, by echelon that we use. So that's what we use, like Gaussian elimination. And Jordan Gauss elimination. Okay, so this is what we're going to see under echelon form. Now let me give you an example of what we mean by that. Imagine this is your initial matrix. Okay, and could be something like this. I want just to give you an idea what we call in order to find the rank, what do we do? Okay, so I'm not gonna solve. I'll give you just an idea of the final matrix. Let's say, for example, this is one of the matrices we have. Okay, and you ask find the rank of this matrix. What you do is you're going to reduce. Okay, you can use any of the method that you see. You're going to use those methods above. Okay, depending if we mention what method you need to use. So those methods above you see there, you're going to use, and then you end up with this form. This is typically the type of matrix form that you'll get. Okay, maybe something like this. Okay, -1. If you apply the Gaussian elimination method, or if you want, you will end up with something like this. You will end up with something like this. Then from here you can define, okay, what is the rank of this matrix, for example. Okay, and this is what you will get from applying any of these methods. You'll get a form like this, so then you can actually define the rank of this matrix. Okay, and I will give you an idea what is the rank, and in what we have here, the rank is if you check into any column or row. Let's just go with row where we have non-zero value. Okay, and as you can see, we have 7 here, so meaning this is one, we can count it. Here we do have this 2, so that will make this row valid, and here we don't have any 0, you will make this row valid, so it's gonna be 3. So it's gonna be 1 1 2 3, so which will give us 3 rank. Okay, and now what is left where we have only 0? This one we call it it's gonna be 1 nullify. It's not like you are asked to find the nullify, just to give you an idea. Okay, where we have something we call it give us 3, so that's why we see we have a 3 there, 3 ranks. Okay, so this is what we have, and I could even give you that formula itself. It's like rank plus nullify will give you the number of column. Okay, columns, something like this. This is like something that you should know. Okay, and in our case we're only looking for the rank. So this is one example of the rank. You can't find you can't find the rank into this block. Okay, only if you go to this other block that you see here. So let me just give it the way it is. After applying the method, you will end up with some kind of form like this where you can rank the matrix. Now let's see now some example of ranks, and then in what way you will know which rank is it. Now we got ourselves some example that we can solve. Now let's go to the first one. So this is after applying the echelon method. Okay, this is echelon form. Okay, and echelon is one of the methods here that we use. So this is what we got, the form. And now you need to rank this matrix. What will be the rank of this matrix? Okay, as you can see, we got in each row something that is not equal to 0. So because of that, the rank that will assign this, it will be rank 3. We're going to rank this matrix. Okay, let's see B. Now for B, you can see on the first row we got non-zero value. On the second row we got non-zero value, but on the third we still have 0, 0. So here the rank is 2. Okay, and then if I have to go with the nullify is actually 2, because you can see we have 2, 0 in the row everywhere. But for this one, the nullify is actually 0, because there's always something in a row. But our main focus is more into rank. Okay, now let's see something else. This example here that you see, what is the rank of now there's something that you need to know. You need to compare those row. Okay, don't you see, like if you multiply, if we take R2 is actually equal to -2 R1. Do you see what I'm saying? So this is where we have R1, and this is where we have R2. So because of that, it will be like 3 times 2 times negative will give you -6. You see? And then if you take -2 times 2, it will give you -4. So as you can see, these two. Okay, and because of that, we're not gonna consider them like this. So we're going to say the rank of this matrix, instead of becoming to be 2, it will be rank of 1. That's the rank of this matrix as you see there. Okay, just give you an example. Let's go next. But if you compare with what we did before, there's no any row that is under the table or negative of any other rank. You can see any other row. So now let's switch to D. Now D, if you look clearly, you can notice that C3 equal to C1 plus C2. If you just look closer, you will see that where C3, this is C3, and C3 is actually the sum of these two. So because of that, so that's what is going to give us C3. Okay, you can see 1 plus 1 plus 2 equal to 3. 2 plus 3, 5. 3 plus 4, 7. 4 plus 5, 9. And because of that, we actually know the rank of this one will not be 3, it will be actually 2. So this one is going to be excluded because it's just a sum of those two. Let's continue. You need to pay attention to what it can be row or column. Make sure that you check the row and column. Okay, it's not just row, you can even check both just to make sure. Now we go with E. This is just to show you how we got this thing that we can rank. Okay, and with the apply rank method, it's what we did apply to this first matrix in order to get to this matrix so that we can rank it. Okay, and for this one, because we have a 7 here, that means this row is going to be count. We have something here, this row will be count, and then something here, this row will be count. So the rank, and if you check, there's nothing that is related to any other row. So this is rank 3. Okay, and if you have nullified, this one is nullified. So nullify 1. There you have it. We just have a few left to finish. Now you go for F. What you see from F, this is easy. I'm just going back to what we did. What is F? That you see there, the rank for F. This is rank of 3, because we have something here, we do have something here, and we still have something there. So this is rank 3. And then if you go for B, and B, you will notice the same thing that we said earlier. It's like twice. It's like row 2 equal to twice row 1. And because of that, our rank of B will be equal to 1. That's what we're going to get there. And then we go for H. Now you see H. What is H? What is the... Then you will see, if you look at this one, it's like row 3 equal to negative row 1 plus R2. Okay, so that's what you see here. So this row is actually negative the sum of this other row. So that's why the rank for C, for H, will be equal to 3. Not 3, but 2, because of that. Let's continue with J. What do you think will happen here? What's the rank? Okay, there's no row that is somewhere inside of times or divide that will call another row. You can see we have 3 of them, so that's why in the rank for this will be actually 3. Okay, and lastly, now here, what is the rank? Okay, and what you should know is we're going to count the rank in terms of column. Okay, so this is what we're going to do here. So the rank will be 2, that the rank will get there. Okay, just to give you an idea, so this is actually 2, because we have a matrix of 3 times 2. That's why our answer is 2. And if you check this one is also 2 times 3, but we take the lowest one, so which is why we see these two, row 1 and row 2. We just consider them like this. So this is what we do about rank, and everything you should know about rank starting from the start. And this is what you should know about rank. And remember, you need to learn all these methods, and I will give you the most popular one. It's actually this one and that one. You need to make sure that you learn normal form, echelon form, by Gaussian, elimination, and by Jordan Gauss method. Okay, you can also learn the big way. Okay, and also this one if you want to.